Okay, we'll come back. This is the debounce circuit. Okay, because we are going to deal with slider switches. We need to make sure that we filter the bounce effect. Okay, bounce effect in the signal when you change the switch state. Okay, so a debounce filter takes a clock, a reset, and a switch in and a switch out. Okay, now I'm not going to take the switch immediately, but I'm going to take a registered value of the switch. So I register the switch and then I filter the registered version of the switch. So if we assume that our clock, as in DE1 SOC board, is running at 50 megahertz, filtering the bounce effect requires around 25 milliseconds. Okay, so the question is, how many clock cycles in this 25 milliseconds? You just multiply this by 50 megahertz to get the number of clock periods, which is 1,000,000 and 25 to 50,000. Okay, so you need a 21 bit counter to count up to this amount, but just in case, we are using 24-bit counter. Okay, so the counter is initialized to 0, and then we have this logic for the debouncing. So at the beginning, when we reset, we just initialize the switch out to be the switch value, okay, or the synchronized switch value. And we restart the counter to be 0. Otherwise, if it's not the reset state, then what do? We check if the synchronized switch is not equal to switch out. Okay. If this is the case, if they are not equal, then we check the value of the counter. If it is greater than or equal to, actually, this should be 1,000,000 to 150,000. Okay. The underscores are just for readability here. Okay. If this is the case, then we copy the switch out and also we reset the counter. Otherwise, if this is not the case, then we just increment the counter by 1. So this is the debounce circuit. Okay, so we need to enter one of the switches as our goal. Okay, we need, for example, switch 0 in the board. Okay, so switch in will be switch 0 here. Okay, and then switch out will be the go signal that we use for our square root, which is this signal. This signal needs to be debounced. Okay, otherwise it won't actually detect the positive edge. Okay, detecting a positive edge on a bouncy signal is very difficult. Any question about it, Shabab? Any question about the debounce circuit? Okay, so let me stop here and then move to the next subject.